Okay, now that we have the seasonal index values, the next step is to estimate the trend. For that, we have to assemble the seasonal factors for the original data set. So seasonal factors are the 4 factors here. So starting from quarter 1 for the very first year. Okay, and if we copy that for 4 quarters, then you'll have the first year done. Then for the rest of them, the 4 numbers they need to repeat. So we go back 4 years for each time period. So now you copy that, and you'll see that they are repeating. The 4 values are repeating. So these 4 values, they repeat. Okay. So now these are the seasonal factors, and these are the original values. And since we have a multiplicative model, so if we take the original value and divide by the seasonal factor, so remember in the additive model we subtracted, here we divide, then we get the seasonality removed value. So this is our trend value. Okay, and we can plot this and see like what we did in the previous case. So we take the series here, and then we take the deseasonalized values and do a line graph, and you see the same pattern like before, and you see there is no seasonality in the second series. So the first one is the series, the second one is a deseasonalized series, so which means there is only trend. It's deseasonalized, there is only trend, and the chart title is time series plot. Okay. Now we set up the estimation for the trend part. So let's start with some initial trial values for alpha and beta, and the LES model is, okay, we're going to use the deseasonalized series, so that minus that over 2, and then average of these plus the trend. Okay, and then the sum of those two values will be the forecast, and error will be that minus that. Okay. Now we can set up the formula for level and trend. So forecast plus alpha, make sure that that is absolute reference, times the error, and for trend it is the previous trend plus beta, make sure that that is absolute reference, times level minus forecast. Okay, now you copy, put the border back, okay, so that's our trend estimate. Now we can multiply the trend with the seasonal factor. So in the additive case we added, now we multiply. Okay, so take the trend and multiply by the seasonal factor. That will be our forecast. Now with that forecast, then we can set up the error accuracy measures here. Okay, now let's set up the error measures. Okay, and we're going to do this from observation 5 through 16. So year 2, quarter 1 through year 4, quarter 4. So first is MSE. So MSE, actual values, and the series forecast. Okay, and then MAE, same ranges. Okay, so MAE, and similar formula for MAPE. Okay, same ranges. We'll make that into a percentage. And RMSE, okay, again, same ranges. Okay, now MASE, we need the third range. Okay, so the first range is the actual value, and the forecast that we're considering, and the baseline forecast, naive forecast, is the actual values starting from year 1, quarter 1 through year 3, quarter 4. So that is MASE until you. Okay. So now we are ready to run data solver. Solver. Okay, so here, so let's assume we're going to minimize RMSE. So we're going to minimize that, and alpha and beta, and we want to keep alpha and beta less than or equal to 1. Non-negative, GRG nonlinear, solve, and we have the final results. And as you can see again, this is very good. Let's compare this with the additive model. Okay, and you see the additive model is definitely better than the multiplicative model.